Hello everyone, my name is Sashank Reddy and my Unity ID is Sapphire, SAPPIRE. The tool I will be using is FindBugs. Many static analysis tools promise to catch bugs early in your code without requiring a lot of effort from the developer. But the main problem that we observe from these tools is that they overwhelm the developer with lots of bugs which are not really bugs. And these are termed as false positives. So let us discuss today on a static analysis tool named FindBugs that, unlike the other tools, doesn't focus on style or formatting, but instead keeps its focus on finding real potential problems as well as trying to reduce the number of false positives. So how does it work? So basically, FindBugs examines the class or jar files looking for potential problems by matching the bytecodes against a list of bug patterns. The reference paper titled Using FindBugs on Production Software states certain common bug patterns defined by FindBugs as including null pointer dereferences, invoking toString or equals on an array, ignoring an important return value, and finally comparing incomparable types using equals operator. But why does these bug patterns arise? They arise for many reasons, including difficult language features, misunderstood API methods, misunderstood invariants where code is modified during maintenance. Well, FindBugs classifies the bugs majorly into different categories named correctness bug, bad practice bug, security performance bug, and a malicious code vulnerability related bug. Also, to prioritize the bugs from these different categories, it has in fact provided a ranking based classification as scariest, scary, troubling, and of concern bugs, where scariest bugs are of the highest order and the priority reduces as we move towards of concern bugs. Well, now how do software companies benefit from using this tool in their cycle? Well, there are many reasons, namely the most obvious one is that you want to make sure the problems are detected as soon as your build is run. As the team size of developers keeps growing, there are higher chances for more bugs to result from the code. So it's always a best practice to identify as many bugs at the earliest automatically by running it for every cycle. So incorporating these results reported by the tool in your source code management system will definitely help the developers to keep track of the bugs to be fixed to produce a quality code. As a matter of fact, with reference to Google Fix-It paper, Google has stated that on a company-wide exercise suggested that engineers viewed FindBugs warnings as worth fixing. Over 77% of the reviews identified the warnings as real defects and recommended fixing the underlying problems. Now, let us once recall the statement that I have said before, which states that FindBugs promises to reduce the number of false positives. Well, how does it achieve this? Can someone think of it? Any ideas? Okay, let me explain that. Well, it does achieve this by not reporting certain unwanted bugs by using exclude filters. These filters are defined in an XML file and then included as an add-in to the existing list as a rule. In addition, you can also turn off certain predefined detectors by deselecting them. Now, what factors are considered in determining the rank of the bugs? Well, the obvious ones are the severity and the impact of the issue. But the major factor, the one which we miss, is how quickly the mistake is found when the code is executed. For example, an infinite recursive loop occurs when a method unconditionally calls itself. We find that in practice that this bug pattern is either found quickly because the reason is the program crashes when a meaningful stack trace appears, or it occurs in a dead code. So we give it a reduced bug rank. Let me go over certain results that I collected after running different sets of tests to analyze the quality of bugs found by Findbugs by running it on an open source project named Voldemort, which is an open source clone of Amazon's Dynamo. It's basically a decentralized, distributed key value storage system. The data is stored across multiple servers where the data is partitioned and each server only contains a subset of the total amount. It has a good data placement strategy that relates to things like distribution across data centers that are geographically far apart. It is used at LinkedIn for certain high scalability storage problems. This software is still a new system which has rough edges, bad error messages, and probably plenty of uncaught bugs. This is the reason why I am using it along with Findbugs. To analyze the quality of the bugs, as a first test case, I configured the Findbugs to report all the bugs of high priority as errors and other default settings which include correctness bugs, .g bugs, and bad practice bugs. Within 3 minutes, the Findbugs reported 16 top priority bugs, out of which couple are very good bugs, namely the first bug related to casting a value between 0 to 1 into an int. Well, this would always return a 0. The developer might have actually intended to multiply the value between 0 to 1 with an integer and then do cast it to an int. By the way, I have run this tool along with Eclipse as a plugin on Eclipse. The other bug I have found is related to incorrect concatenation of a byte array into a string object without using the toString operator, which is a clear issue because you need to define a byte array to toString before using it as a concatenator with a string object. Later, I have performed another test to analyze the time taken for the overall execution, memory consumption, and the results were startling to observe. With full advanced settings related to capturing even minute bugs, for which I selected all the bug patterns and all the bug categories available, the time taken was close to 10 minutes and the peak memory consumption was well within the limits, about close to 498 MB. Out of all the bugs reported, close to 65 to 70% of the bugs seem to be good bugs. Well, the amount of time spent by the actual testing team to identify certain performance bugs, which I have mentioned before, might generally take hours and in fact days sometimes. I found it really useful with the way the tests have gone, and it's also good to use such tools to identify the bugs early in the production cycle, and that too cheaply. Within minutes to hours it catches the bugs. Let me finally wrap it up with the pros and cons that I observed through the usage of this tool. The pros mainly include good categorization of the bugs in terms of .g bugs, security, performance bugs, support for custom filters to include or exclude user-defined bug patterns, provision of detailed description about why a particular class of bug is harmful, and finally, prediction of less number of false positives makes it more useful for the developers. There are not many cons that I observed, but couple of limitations are that it is hard to transfer the configuration settings to others that might be needed when more people are working in parallel. With its wide prominence already observed by its inclusion in the production cycle by many software companies, it would be more useful to provide the support for more coding languages. Currently, it is just limited to Java language. With the experience I had using Findbugs, I would definitely recommend to try it if you haven't used it already. Thank you everyone.